For years, Toyota built its reputation upon quiet reliability, a brand trusted by millions, making waves without ever making noise. But now, that silence has been broken. In a rare and fiery declaration, Toyota's CEO stepped into the spotlight with an unexpected message. Our new dynamic force engine will destroy the competition. This wasn't merely corporate bravado, it was a bold shift in attitude. Toyota is done playing it safe in the shadows. So, what exactly is this new engine? And why is Toyota suddenly so sure it is about to outpace the rest of the auto industry? Let's delve into the story behind Toyota's most ambitious powertrain strategy to date. Toyota is not just upgrading its engines, it is completely rethinking how they function for the future. While much of the auto world is racing toward full electrification, Toyota is charting its own course with the Dynamic Force engine series, doubling down on fuel engines with groundbreaking innovation. This is not a minor tune-up, it is part of a massive, long-term vision anchored in Toyota's global design framework known as TNGA, or Toyota New Global Architecture. TNGA allows the company to create vehicles that are tougher, more efficient, and easier to manufacture, all while staying agile in a rapidly evolving market. While many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota stated that the new dynamic force engines are a major part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still deliver strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas while also meeting environmental regulations and keeping costs low. The new dynamic force engines are designed to work with Toyota's TNGA platform. So, TNGA is a system that lets different cars share the same parts and design. This really helps reduce production time and honestly, makes it a lot easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of, starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes like switching to new types of fuel. The dynamic force engines focus on more than just speed or power. They are built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency. So, what this means is the engine can turn more fuel into usable energy, rather than losing it as heat. It's pretty fascinating how these engines use a longer piston stroke, along with a mix of fuel injection methods to boost performance and cut down on emissions. Now, cooling systems have become more advanced too. With electric water pumps and improved temperature control, the engine stays at just the right temperature. This not only makes the engine last longer, but also helps it perform better in various weather conditions. Every single part of the engine was meticulously designed to support both performance and fuel savings. The Dynamic Force series, for instance, includes 3 types of engines, a 3-cylinder, a 4-cylinder, and a V6. It's all about achieving that perfect balance. So, the i3 is small and uses less fuel, which is good for compact cars. The i4 is actually the most common type, found in many midsize cars out there, and the V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production so the same engine can be made in different countries with local parts. This, saves time and money while keeping quality high. It also helps Toyota deal with supply issues or changing demand in different regions. Toyota's vision is to use dynamic force-derived hydrogen engines for niches where battery electric vehicles may fall short, such as long-distance driving, heavy-duty use, or cold climates. Unlike some rivals who aim to phase out internal combustion engines by 2030, Toyota believes a multipath strategy is more practical and inclusive for emerging markets. In the company's roadmap, dynamic force engines will gradually shift toward exclusive use in electrified powertrains, including hybrids and plug-in hybrids. Pure internal combustion variants will slowly phase out as electrification expands. By the early 2030s, most Toyota vehicles are expected to use dynamic force technology in some hybridized form, delivering low emissions and reduced fuel consumption at scale. Simultaneously, Toyota will continue investing in solid-state batteries, full EVs and hydrogen fuel cells, but unlike competitors who are betting everything on one solution, Toyota is hedging its bets, allowing its dynamic force architecture to act as a reliable backbone for markets that are not yet EV-ready. This hedging isn't indecision, it's strategic flexibility. The global transition to zero emissions will not be uniform, and Toyota's strategy ensures that it has a scalable, efficient, and proven ICE hybrid option ready to meet customers wherever they are on the path to electrification. Toyota's bold claim must also contend with a different kind of competition. Manufacturers who have completely abandoned combustion engines, Tesla, BYD, and other EV-only players are redefining what powertrain innovation means by removing ICE from the equation entirely. Tesla, for instance, has pushed the industry toward ultra-efficient electric drivetrains with permanent magnet motors, silicon carbide inverters, and high-voltage battery packs. BYD has taken a more integrated approach with its e-Platform 3.0, combining Blade Battery's compact motors and advanced power electronics into a tightly optimized package. In markets like China and Norway, electric vehicles already outsell combustion vehicles. In these environments, Toyota's dynamic force engine isn't a threat. Honestly, it's irrelevant. However, the world isn't homogeneous. In Africa, Southeast Asia, Latin America, and parts of the United States, infrastructure and cost barriers remain. In these regions, Toyota's hybrid and internal combustion engine offerings continue to outsell electric vehicles by a wide margin. Toyota's argument is simple. Until electric vehicles are cheap enough, clean enough, and fast enough to charge anywhere in the world, dynamic force engines, especially in hybrid form, offer a more realistic, scalable solution. And for now, the sales data agrees. While, many competitors can match Toyota in innovation, very few can rival its production scale, vertical integration, and, honestly, its reliability history. Toyota builds millions of dynamic force engines every year, supported by a supply chain that's optimized for everything, from raw casting all the way to final assembly. The Toyota dynamic force engine represents far more than just a simple technical upgrade. It's, a profound statement, a declaration from the world's largest automaker that the story of the internal combustion engine is definitely not over yet. This is really a reminder that through relentless innovation in thermal efficiency, friction reduction, and intelligent hybrid integration, there remains significant untapped potential within the conventional power plant. It's a clear signal that Toyota is not prepared to surrender its dominant market position or its engineering legacy without a fierce and calculated battle. While its primary rivals pour their resources and public messaging into an all-out rush toward full electrification, Toyota is executing a far more nuanced and strategic long game. This approach involves a multi-pathway strategy, advancing battery electric technology, while simultaneously perfecting the hybrid as a global transitional solution, and even exploring alternative fuels like hydrogen. The dynamic force engine is a cornerstone of this strategy, a masterclass in optimizing a technology that will power millions of vehicles for decades to come, particularly in markets where charging infrastructure and energy grids are not yet prepared for a wholesale electric transition. Yet, this bold move exists within a whirlwind of change. The industry's gravitational pull toward electrification is accelerating, driven by regulations, consumer sentiment, and a cultural narrative that equates the future solely with the electric vehicle. This raises a pivotal question. In the rear-view mirror of history, will the dynamic force engine be remembered as a stroke of genius, a brilliantly pragmatic bridge that offered accessible, high-efficiency mobility to the masses, or will it be viewed as a costly misallocation of resources, a final, magnificent flourish for a technology destined for rapid obsolescence? The verdict hinges on the speed of the global transition and the unforeseen twists in the energy landscape. We want to hear your analysis. Do you see this as Toyota's masterstroke or a potential missed opportunity? Let us know your